Now we're going to review and do our DCA supplement. These problems were a little bit more difficult and involved a little bit more thinking. So let's get busy. Okay, number one asks for the area of the shaded region. So we're going to have to take the triangle that's listed, find the area of the triangle. That is base times height divided by 2. Then we're going to have to take the area of the rectangle, which is length times width, and then subtract the solutions to those two. All right, so first thing I'm going to do is find the area of the triangle. That's 6x times 10x plus 1 all divided by 2, which gives me 60x squared plus 6x divided by 2. Remember that when you reduce, you have to reduce the 2 into the 60 and into the 6x. So that gives me 30x squared plus 3x. That is my triangle. Now I'm going to do the area of the rectangle. So over here I'm going to do area of the rectangle, and I have to multiply 2x by 5x minus 1. That gives me 10x squared minus 2x. All right, now I have to take the triangle, which is 30x squared plus 3x. That's one of the polynomials. I have to subtract the second polynomial, which is 10x squared minus 2x. Changing all of my signs, that gives me 30x squared plus 3x minus 10x squared and plus 2x. My final solution is going to be 20x squared, because 30 minus 10 is 20, and then plus 3x plus 2x is 5x. So the area of the shaded region here is 20x squared plus 5x. All right, number 2, I hope you paid attention. It said that 5x squared minus 8x minus 7 is subtracted from 2x squared plus x minus 5. So the 2x squared plus x minus 5 has to go first, then the subtraction, and then 5x squared minus 8x minus 7. I'm going to rewrite it taking off the parentheses and distributing the negative. So that's minus 5x squared plus 8x and plus 7. Now combine like terms. So I have a 2x squared and a negative 5x squared. That gives me negative 3x squared. I have a 1x and 8x, which is 9x. And then I have a negative 5 and a positive 7, which gives me plus 2. Number 3, I'm asked to find the area of the square. The area of a square is going to be a side squared. So I've got to take 4a cubed b and square it. So you square the 4, that gives you 16. When you square an exponent, remember that you multiply them, so that's a to the 6th, and then b to the 1st to the 2nd is going to be b to the 2nd. Okay, number 4, I need to evaluate the expression. So that means I've just got to take the negative 3 and plug it in everywhere you see an x. Remember that you need to use parentheses around the negative 3. Around the negative 3, and that does make a difference. So I'm putting my parentheses and plugging in negative 3. Okay, negative 3 squared is positive 9 times 2 is 18. Minus negative 3 is the same thing as plus positive. So now I have 18 plus 3 plus 5, which is equal to 26. All right, number 5. This is a system of equations. I've got to come up with 2 equations for my 2 problems. Okay, the perimeter of the flower bed is 76. That means I have 2L plus 2W equals 76. The second sentence says that the length is 2 feet less than 4 times the width. Now to find the solution to this, I'm going to use substitution because I have a variable that's by itself right here. So I'm going to circle the variable by itself and circle the same variable in the other equation. I'm going to rewrite my equations, dropping out the L. And then I've got to put the 4W minus 2 in the place of the L. Distribute 8W minus 4 and then combine like terms and move the 4 over. No. And then solving for W, the answer is 8. It does say to find the whole solution, so my width is 8. Now I need to find the length. Plugging 8 into the width, that's 32 minus 2, so the length is 30. Okay, this next problem, number 6, I'm not going to actually solve, but I have to find out if they have one solution, no solutions, or infinitely many solutions. Okay, let's look at the first one. If I were to change all the signs on this bottom line, the 4's would cancel, the 5's would cancel, so that gives me 0 equals 20. Since 0 does not equal 20, that is no solutions. The second problem, if I multiplied everything by 2 right here, that would give me negative 8x plus 10y equals negative 20, and negative 8x plus 10y equals negative 20. Oh, wow, those are the exact same equations. Everything cancels, so you would have all real numbers or infinitely many solutions. Number 3, I'm going to change the signs on this top line. That makes the 5's cancel. I get negative 3x equals 20. Now I can actually solve that, so that means I would get one solution. That means that these two lines will intersect at one point, and I should be able to find that point. Now, since it doesn't ask us to do that, we don't have to do it. All right, number 7. We have to find the solution. The solution is where the equations are the same y values on each, and that happens at the point 4, 6. On number 8, we have to find when these will be the same. Now, I can't see by looking. I could extend my table to find out how long it takes for them to be the same, but I'm going to write an equation and solve the equations. Let's talk about Taylor first. Taylor's y-intercept is 25. So for Taylor, I'm going to be starting at 25. This is going to be y equals 25 plus something x. Well, the thing that goes in front of the x is what the y values are increasing by. These are all increasing by 5, so it's going to be 5x. That's Taylor. Now let's look at Josie. Josie is going to be y equals, he is starting, or she is starting at 16. Their value is increasing by 6 each time, so that's plus 6x. Now I have two equations, and I need to solve to find out when the two equations are the same. So I have 25 plus 5x equals 16 plus 6x. I'm going to move the 5 over to the 6x. So that gives me 25 equals 16 plus x. Now move the 16 over. 25 minus 16 is 9, and that is equal to x. So the length of time that it will take is 9 weeks. All right, on number 9, I need to find my equations and then plug them in to figure out when they will be the same height as the Remax balloon. Okay, so my first equation is going to be y equals negative 20x plus 400, because it started at 400, it is descending at a rate of 20. My second equation is starting at 0, and it's ascending at 10x. So then I would take my negative 20x plus 400 and make it equal 10x. I'm going to move the 20 over to the right. That gives me 400 equals 30x, and then divide both sides by 30. Okay, so that gives you 13 and 0.33, or 13 and 1/3. Now that's what x is equal to, but it did ask me how far it had dropped. So if I have a balloon that's starting at 400 and it's dropping at 20x, then all I really need is this part, 20x. So negative 20 times 13.33, and that gives me 266.67 feet. All right, number 10, last one. You can read the paragraph, but what we have to do is figure out again if it's one solution, no solution, or infinitely many solutions. Okay, number one, Mario graphs the lines and they intersect. That means they cross, therefore you have one solution. On number two, it's in slope-intercept form. They have the same slope, but the y-intercepts are different. So let's say the y-intercepts are here and here, but they're going to increase at the same time. Therefore, you're going to have parallel lines, and parallel lines have no solution. The third problem, it's already in slope-intercept form. He can see that the two equations are identical, therefore they're the same line, and they have infinitely many solutions. A lot of times we say that that's all real numbers. Number four, both variables cancel and he ends up with 0 equals 10. So that means that the x's cancel, the y's cancel, you have 0 equals, and then the number on the right does not cancel. Again, that's going to be no solution. And number 5, he notices that he ends up with 5 equals 5 when he's substituting. Again, that one's going to be infinitely many solutions because they're the same line. On number 6, he gets 2x equals 10, so x would equal 5. He would have to plug the 5 back in, but this time you would actually get a solution. So how many times do they cross? One solution. All right, that's the end for today. I hope y'all study and do a great job on the DCA tomorrow. Bye.